Hello and welcome to another video where today we're going to be looking at algebra expressions, specifically solving linear equations and find the value of this unknown letter x. Now, I make no secret of the fact that I actually really love algebra. It's generally, I find, one of the more least popular areas of maths, but for me, I always like to see this like some kind of big sort of a puzzle solving thing, and I think these linear equations are a great example of that. So, I want to look at how we can solve this using sort of the various steps in order to find the value of x. So I have this equation written out, so I've got 3x minus 6 equals x plus 4. First thing I'm going to do, just to make it easier for you all, is I'm going to do what I like to do, which is to show the numbers we have with x and the numbers without x. I'm going to write exactly the same thing, except numbers with x I'm going to do in green, so we've got 3x here. X by itself there. Then we have minus 6, do it in red, and plus 4. Now you'll notice I've done the functions here in red as well. This is because they are in fact related to the numbers that we have where they are, sort of next to them. Effectively, we have negative 6 and positive 4. Obviously, of course, we'd normally write in if the number's positive. So just to make that clear, I'm going to just highlight the fact that 3x is positive and this x is positive. Believe me, it's going to become important later. So now what I want to do is now I want to rearrange these numbers so they're either side of the equal sign. So the equal sign, it's kind of like it's sort of splitting up the two in the same way that a fraction divides the numerator and the denominator. So we're going to move these around first of all. So let's keep the x on this side, so I'm going to keep that 3x here, which means I'm going to keep the 4 over here. So that's positive 4. Now, first thing I'm going to do, well, I'm going to move the 6, I think. So the 6 we have here, so I'm going to move that onto the opposite side. So our 6 comes, oops, wrong pen, there. And the x will go onto this side, so it's over here. Now, whoa, do that again. What am I like? So we've got 3x. Now, this is the important thing where the symbols, the functions rather, become useful. So, golden rule is every time we change the side, we change the sign. So when I brought the x over here, it's positive, but that means on this side it's going to be negative. Effectively, we're taking x off of either side. And the 6 here remains positive because it was negative here, so therefore it stays positive here, becomes positive rather. So now we're just going to effectively work out either side. It's quite straightforward. So we have 3x minus x, which doesn't give us 3, but rather it gives us 2x. Some people are often quite confused, or at least get a bit anxious when they sort of see letters involved in numbers, especially if x is written in this funny way. Simple way to think about is imagine that the letter, whatever it may be, is an object of some sort. Let's say they're pens, for example. So we've got 3x minus x. So imagine that as 3 pens minus 1 pen, which will give us 2 pens. And then, simpler bit, 6 plus 4 is, of course, 10. Now, we just need to take this 2 away from the x, and therefore we'll have separated x and the numbers entirely, so have x left just by itself. So I'm going to do that now. X goes there. And the simple way to do that, well, x is being multiplied by 2, so the opposite multiplication, we divide. So there, I've done that other 10 a bit too big, so I'm going to squeeze it in there. And then finally, 10 divided by 2, well, first of all, we have our x, and then our result, 5. So x equals 5. And the quick way to check that to make sure it works is to check if it balances in the original expression. So here we are. So if we substitute x for 5, so 3 times 5, 15, minus 6, gives us 9, and then x by itself, well that's 5, plus 4 also gives us 9. And there we have it. It works, we solved it. Thanks for watching.